Hello everyone, good morning. Can you guys hear me? And can you see my screen? Thank you Naveen, thank you Kanuj, thank you Ajit. Nice to see you again. All right, so looks like we don't have 100% participation yet. So maybe we'll wait for a couple of minutes and then we'll begin the discussion. Yep, thank you. Hi everyone. So let's begin. Yeah, I think we have waited enough. Let's begin with today's discussion. So again, good morning everyone. Good morning, good evening, depends on where you are joining from. Welcome to today's webinar. We are going to talk about DevOps today, what DevOps is, how does it come into being, and all that stuff around DevOps. We'll understand basics of certain tools, some terminologies, and before we go into that, let me introduce myself. My name is Amit. I am based out of Bangalore. I've been in the industry for around 15 years now. Yeah, started as developer, then moved into validation and then integration, then build and release, and now I am a DevOps practitioner. Yeah. So I have worked with various kinds of tools, version control systems, starting with ClearCase, Git, CM Synergy, SVN, and Jenkins. Um, Container technologies like Docker, Kubernetes, OpenShift, Chef, Ansible, Puppet for configuration management, and then for monitoring we have Nagios. I've used Nagios. I have worked with Zabbix as well. So yeah, I have have had my share of experience in DevOps. So yeah, I will be with you today for discussing about DevOps as a concept. Yeah. Question from Derek: do we need to separately dial in using phone? You can use your computer audio if you have a headset, or you can choose to dial in from a phone. Yeah, when you join the webinar, it will give you an option, so you can do either of that. All right, so let's take the discussion forward. Let me adjust this questions window a bit. Yeah. So in today's discussion, we are going to talk about DevOps, and it will be for around 1 hour. And if you have any questions, just message me the questions in the questions window. I will try to answer them immediately, or maybe in a bit once I'm done with the topic that I'm explaining at that moment of time. Yeah. So today we are going to discuss about these things. Why do we have DevOps? What exactly is DevOps? What are the various stages in DevOps? So some terminologies. What are the tools that we use in DevOps and DevOps use cases? Yeah. At the end, we are going to um, have a small demo where I'm going to demonstrate to you how we can use Jenkins to achieve various stages of DevOps. Yeah. So before understanding DevOps, we need to understand a little bit about Agile. And before understanding Agile, we need to understand a little bit about Waterfall development model. Yeah. So I hope, and I'm sure you guys have heard of software development life cycle, right? Each software development practice has certain stages. So you have requirements gathering, you have analysis and design, you have implementation, which includes coding and testing, or I would say coding and verification. And at the end, we have release, and then we have maintenance. Yeah. And we can achieve this using various models. One of them is waterfall model. A waterfall model is nothing but a very straightforward software development lifecycle model where you have all these distinct stages or phases of development identified, and one stage is executed after another. Yeah, something like this. So you understand the requirements, and you get the requirements and do the analysis. You do the design, implement, test, deploy, and then maintenance. Yeah. One um, one rule here that we follow is we do not go back to a previous stage in any moment of time. Yeah. So if you have done the requirement gathering already and you are in the design phase, you will not, for any reason, you will not go back to the requirement gathering again. Or if you are in the deployment phase and the customer says, hey, I want to change the requirements, you will not do that. I mean, you do that, but there's a very, very expensive defined process to be followed, which is called a change request. Yeah. So changing of requirements frequently is not allowed. Changing of design is not allowed, because once you fix the design, on top of the design you do the implementation. So flexibility is missing in waterfall model. Yeah. And because these cycles have to be followed in order, for example, if we talk about implementation and testing, um, there is a delayed testing, as you can see here. So let's say if I and testing and implementation and testing is actually a single stage. Yeah. So let me use a pen here to mark on the screen. I'm not sure if it will work. So yeah, so this is actually a single stage. Yeah, implement and test. And implementation and testing goes one after the another unless we are ready for the release, unless the test team says, okay, now we have the perfect results of a product, right? So we do the requirement analysis, a gathering and analysis, then we go to design, and we go into implementation, where we have n number of cycles of implementation, coding and testing. And once testing says okay, then we go into deploy. Yeah. And once we deployed, then we go into maintenance. Okay. So here, when we do implementation testing, there is a delayed testing for each cycle, right? For example, let's say we agreed in our team that implementation will happen for 2 weeks, and after that we will give the product for verification, right? And once the verification is done, we will work on the next implementation cycle. So if I'm working on a feature and I deliver it quite early in the beginning of the 2 weeks, then I have to wait for another 2 weeks for the test results to come back to me so that I can know how my implementation was, if there are any new failures, are there any new regressions. Yeah, so there is always a delayed test results. So you cannot always check your code against all the defined test cases in real time. You have to wait for the actual verification team to come back to you with the results, so that you can understand if you want to fix something that you broke, or if you want to redesign something that you did. Yeah, so this is basic of waterfall model. So why are we learning this? Yeah. So these are the kind of limitations of waterfall model. So there is high amount of risk and uncertainty, because when you work in a waterfall project, you define a time. Yeah, your project is time bound. Let's say you have a contract with your customer, their project, or you deliver the project to the customer in 1 year, right? And in the 1 year, first month is spent on requirement, second month is spent on analysis, and then 8 months are spent on implementation and verification. The ninth month you do a deployment, and the 10th month starting uh, you do the maintenance. Yeah, so until the ninth month, the customer does not get to see the product, right? So that means the customer is always in a kind of a stage of uncertainty, where he does not know what he's going to get. Yeah, and then you have the limitation that um, once your application has crossed a life cycle stage, then it does not go back to that stage, because it is very expensive. Yeah, and if your requirements are changing frequently, again, waterfall model has its limitation, because each new requirement will have a complete new waterfall cycle to be followed, right? So there are certain limitations which are now very evident to the development teams. S- it has worked fine for past 20-30 years, but now with the current tool landscape, with the current kind of projects that we are working on, it is not suitable. So that is why we work with agile. Yeah, and in agile, we don't commit for a huge time duration for a project, right? A project is broken into several iterations. Yeah, iterations and increments. Okay, so each iteration is of a defined amount of time, maybe 2 weeks, maybe 3 weeks, things like that. And at the end of each iteration, we make a release. It can be very small release, very small feature sets, things like that. Okay, and for each iteration, we follow all the most of the waterfall stages. So for example, these are the various iterations. Yeah, you can see on the screen. So in the first iteration of the project development, when the project started, we understand the requirements, which is the discover part, then we design, and then we develop, and then make a release at the end of the iteration. So assuming that this is a 2 week iteration, so in the beginning of the 2 weeks, you understand the requirements from your client, uh, you design based on the requirements, and then you develop or implement the requirements, and at the end of the 2 weeks, you deliver it to a customer for review. Yeah, and then you start the next iteration for the next 2 weeks. Right here, you take the new requirements, implement, design, and implement. Again, same thing goes on for each iteration, right? So here we see that the release cycle has been reduced, and the scope of the release also is reduced compared to waterfall method, and this gives certain flexibilities to us. First is beginning of each iteration, your client can give new requirements or change any previous given requirements, and that can be done because you may not have worked on that requirement in detail, or it is still not implemented, so it is easy to change and things like that. Second is, at the end of every iteration, your customer sees a, a, a tangible output. Yeah, so your customer sees a product, and he gains some confidence on how the product is shaping up, right? So this is agile. Agile means, in other words, it means flexibility. So your project development is quite flexible, right? You give your clients opportunities to change requirements and to see the product time to time. So this is what agile is about. So here, uh, for our for our understanding of DevOps, we need to keep in mind that we are releasing a product every 2 weeks. Okay, that is the important part. Any questions? Question is, how can I implement the agile approach on fixed cost project, which is the case all the time with external customers? If you have a fixed cost project, then I mean, again, you have to uh, break down your project into multiple iterations and agree with your client on in each iteration what changes he wants to see, right? You have to design it in such a way that each iteration adds some value to the previous iteration, right? But again, if it is very time bound, then um yeah, it is a bit tricky. It is a bit tricky. Okay, so let's move on to the next discussion. All right, so now now we understand this. Waterfall is one stage after the another stage, right? Where no chance of going back. Then agile is, the complete, almost the complete waterfall in each iteration. Yeah. Now, why do we have to go to DevOps? Agile was perfectly fine. Why do we have to go to DevOps? I'm sorry, I'm not feeling so well today. I'm sorry. So now with the agile, right, we make very frequent releases. And when we make very frequent releases, we are always deploying the artifacts to our servers or to the client servers, and that always poses a challenge. The challenge is, first of all, when you're making frequent releases, you don't have much time to manage your infrastructure so that your release is up and running as and when you release and things like that. So you rely on the operations team. Operations team is the team which makes sure that your IT infrastructure is up and running. Yeah. So your servers are up, your file system is up, your tools are installed, configured correctly. That is done by operations team. The development team will just develop the product and click on a button to make a release. The release should go and sit on the server and work properly. Yeah. But most of the times, the the product does not simply and so easily work on the target system, right? That may be because the development team has worked on their laptop or desktops or their own development environment to develop the product, and they have configured the environment according to the requirements, and the product works fine. But when they make a release to the operations team to deploy it on the production environment, or maybe an operation team managed test environment, there uh, maybe some configurations are missing, so the tool or the product does not come up or does not work as expected, right? And then comes kind of a war between these two teams. Development team says, my code is perfectly fine, it works on my laptop. Here you can see, you can also demonstrate. Operations team says production environment is fine, I don't see any problem, so no servers are down, all the configurations are as per the requirement. Something is wrong with the code, right? I will not deploy this code. So operations team prime responsibility is to achieve stability on the infrastructure. The development team's prime responsibility is to deploy their changes so that customers can use it, right? And then that brings up a conflict. That conflict is about each other team's own um, KPIs, right? Operations team wants to be most stable. They don't want any downtimes. Otherwise, they will be questioned that your infrastructure is not stable. Development team does not care about all that. They want their product to be up and running as soon as possible. Otherwise, they will be put in a position to explain themselves. Now, how do we solve this? How do we solve this problem? So this problem can be solved by bringing both these teams together, right? The development teams and the operations team closer to each other so that they can manage the infrastructure, they can make the releases very quickly and manage the infrastructure accordingly. That does not mean that development team guys should go and start managing servers and things like that. It does not mean that. It means that development team should be able to use the operations infrastructure based on their need, so they don't have to make frequent changes to the infrastructure, and the ops team is also satisfied that the infrastructure is always stable. Yeah. So now today we will learn how is this made possible. So when we talk about DevOps, we talk about your in any agile iteration or any agile cycle, you perform your planning, coding, compilation, testing, and then at the end of the cycle you do a deployment, and then you operate and manage your release. Yeah, we don't look at them as different activities, right? Like separate development activities and separate release activities. Everything is part of your development activity, right? Even your release is part of your development activity. DevOps, what it does is it tries to give you an environment where you don't have to deal with the infrastructure part, you don't have to deal with setting up of tools and all that. You can automatically, without being dependent on IT personnel, you can make your own releases. You can upgrade your system to make the release. You can set up your monitoring. You can make sure that the release is propagated the to all the servers and things like that, right? That is the aim of the DevOps. Okay. And for that we use many tools to standardize all these processes. So for example, for planning and coding, we can use Jira for your tracking of your requirements and change requests and bugs. You can use Git with a server like GitHub or Bitbucket to store your code, to track your code, to link your changes with requirements. For compilation, we can use some build tools like Maven, Gradle. For testing, we can use certain standard tools, like for example, for web testing, we can use Selenium. For unit testing, we can use JUnit, CPP unit, or NUnit, or things like that. For integration of all these tools, right, we can use uh, a, a, a kind of a tool orchestrator. Jenkins is the most popular. Hudson is something similar to Jenkins. Not getting into much detail here. Then there is Bamboo, which is again from Atlassian, which integrates very well with Jira and Bitbucket and stuff. And then when it comes to release and deployments, you have your deployment tools, you have your server configuration tools. So for deployment, you can either use Puppet Chef, Ansible kind of server configuration tools, or you can deploy using containers, using Docker. And for monitoring, there are various solutions available: Nagio, Zabbix, anything can be used. And when the operations team gives this complete environment to the development team, right, that you have your you have your version control, you have your requirements. I have integrated that with Jenkins, and then Jenkins is integrated with Docker and Chef, and as soon as you make a change, something will happen and your code will be deployed. You don't have to come to IT, right? That is the integrated environment, which is known as DevOps, which is used by the development teams to manage their products on their own. Yeah. So this is what DevOps is all about. Questions? Some questions here. Don't you agree that agile approach can be applied internally within the software development and operations team of same? I'm not sure what you mean by of same. Do you mean operations team of the development team? So generally, operations team are not part of any software development team. You can have a couple of people who can take care of your infrastructure, but they are not part of IT operations. Yeah. Uh, but I mean, you can have agile in software development, but it's very difficult to implement agile in operations because there are no requirements. They don't run it based on your agile principles. Actually, operations are run based on Kanban principles, which is kind of a different form of agile. They're not traditional agile. Question of the same idea. Okay, it's an extension. Yeah, so the second part of the question is of the same IT, but cannot be implemented with external customer as the contractual agreement always governs the relationship. Again, so yeah, if you have to go as per the agreement with the client. If your client agrees that you can take it in agile way, then do it. It's your responsibility to convince the client to go this way so that your life is easy and client sees the benefit. If not, then again, tough luck. You have to go as per the best understanding between you two guys. Question: what is deploy and operation? Deployment is to deploy a release, and operate is to make sure that your servers are up and running and your product is available to the clients always. Hmm? Okay. All right. So if we want to achieve DevOps, what do we have to do? What are the various stages of DevOps maturity? So first thing that you need always is a version control. Yeah. Yeah, your point is right. Operations means like maintenance or support. Yes. So you have version control, right? Once you have version control, then you can achieve continuous integration, right? And once you achieve continuous integration, then you can do continuous delivery. And then finally, at a very high level of maturity, which only some teams achieve, you can have continuous deployment. So continuous integration, what does it mean? You know what version control team means, right? Maybe I'll explain a bit. A version control is a tool which allows you to track and manage the history of all the changes that goes into your product code, right? Examples like Git or SVN or ClearCase. If you have that, then you can go for continuous integration, where we make sure that any change that you perform in your project source code is built and tested and reviewed and ready for release. Yeah, that's called, with ready for release, I mean packaged. That's called continuous integration. So each change is continuously verified. We will see that example in detail in the next slides. Then comes continuous testing, where this is called continuous delivery. The delivery means that whenever there's a new change made to your project, it is compiled, tested, packaged, and deployed to the test infrastructure so that it is ready for customer acceptance. Right? The main customer release to production happens manually after getting certain approval. Hmm? Then comes the continuous deployment. Continuous deployment, if achieved, right? It means that whenever there is a code change on a project, it is compiled, it is built, it is tested, it is packaged, it is again subject to some more testing like system testing, user acceptance testing, and all that. And at the end, if all testing goes fine, all verification goes fine, it is deployed to production directly, right? So you have that kind of agreement with your client that each change which passes all the tests will be deployed to production. That is called continuous deployment, and only some products or some teams have achieved this, right? For example, Facebook, Google, Flipkart, all these kind of e-commerce or e-services have achieved this. Netflix has an excellent. Netflix is, I think, the benchmark of the DevOps use cases. Yeah, and that is one of the reasons they are so successful. So let's talk about each stage in detail. I think I already mentioned this, but let's go into detail, right? So when we talk about source code management, what do we talk about? We talk about managing your project documents or project artifacts so that any change that is done to them is properly tracked, right? So you have your version history, your timestamps, your comments for every change that you do, and things like that. Okay, so that means each change that is done to your project, maybe on the code or on documentation or anything else, is you can always see what has changed, when it was changed, why it was changed, who changed, and things like that, right? So you have the complete history of a project. So there are two kinds of tools which enables you to do this. There are centralized version control system and distributed version control system. It is very difficult to explain in very small time which we have. So I will leave it as such, not going too much detail, right? Just to give you an idea, when we have central version control system like SVN or ClearCase, we always log into the central server and download the data or work on the data or work on the project files. Yeah. So like SVN, you do a checkout, then you work on the file, and then you commit the changes back to the server. Then there is distributed version control system where your project is available in the central server, but you can also download the project completely on a local machine and work there and publish the changes back to the central server. For example, Git, how Git works. Yeah, unfortunately, I do not have much time, or we all do not have much time to get into the nitty gritty of these tools. So I will just keep it at a very high level. Okay, so this is how Git works. If you are already using this, this should be very um, this should come very easy to you. So when you work with Git, you make changes locally by using git add and git commit commands, and once you make a commit by using git commit, then you push the changes back to the remote repository or the central server, and the other users can do a git pull to get the latest changes. All right. Then for the continuous integration, what do we have to do? For the continuous integration, we work with a source control management tool like Git or any other version control system, and then we associate an automatic build and test kind of infrastructure here. Yeah, so if I use a pen here, so each developer is free to make changes to the project, right? Maybe this is a Git repository. This is a Git repository or a Git project. Each developer makes a change here. As soon as one change is made, right? Maybe one line is changed or new file added or some files modified by a user, it is automatically picked up by your build server or the Jenkins server, and then the project is built. And what do I mean by building a project? That means it is compiled, a code review is done on the project, a unit testing is done, integration testing is done, and the project is packaged so that anybody can take it and deploy it manually. Right? This is what continuous integration is all about. So as soon as the user makes a change, pick it up and compile it and test it. Yeah, and the feedback of these stages are given back to the developers. If your test fails, then the developer is notified that your change did not pass the continuous integration test. So please make changes again, fix it, and then submit again, right? So this is what continuous integration is all about, right? And then comes continuous delivery, which is again the next stage in our DevOps, right? So let's say a developer makes a change to the Git repository, Jenkins server picks it up, it compiles, and everything is going fine. All testing is fine. Package is generated. Then you can maybe directly deploy it to the test server for user acceptance tests. Yeah. So this is called continuous delivery. That means you are delivering to the test infrastructure, delivering to the user, at least at the end, where the user can do acceptance test. Now, if you are mature enough, if your test cases are written in a way that nothing can go past them. So if your automatic test cases are passed, that means the product is mature and robust. Then you can go the next step and deploy directly to the production, right? So a developer makes a change to Git, and that change is automatically picked up by Jenkins, and then it is compiled. By compilation, I mean then it is built. That means it is compiled, code reviewed, tested, package generated, and then if everything is okay and you have agreed with the client, then deploy on production directly. Don't worry about any other specific UAT or any other approvals. Yeah. So these are the various stages of maturity of DevOps. Questions? I'll clear all these markings. Some questions here. What if same file is changed by both developers? That is not possible to change the files at the same time, right? You can change the file on your local machine, but when you submit it to the central server, uh, one person will be before another person. Always. In the in the build, unit, and integration testing are kind of high level testing like check-in connections and not business test cases. You can have that. Why not? Maybe unit and integration testing do not have, but then for system testing or function testing, you can have business test cases. What about database scripts? Does Jenkins work with it? Uh, so for databases, maybe Jenkins is not something that will work. Okay, so just to make you a little bit of uh, awareness here, Jenkins does not do anything on its own. Jenkins works with various other tools, right? So it integrates with Git. For compilation, it will use Maven or Gradle or Ant or Make, whatever you want to use, or MS Build. For deployments, it will use some other tool like maybe Apache deployment tool or Docker or things like that. It does not have any of its own intelligence. So if you want to work with database, I think there are enough plugins available which can add those functionalities also to Jenkins. Unfortunately, I don't have any specific answer right now on top of my hand. We will have to explore, but definitely I'm sure there will be something. Question: so developer should have some kind of understanding like I'll work on file A and you work on file B. No. So if both developers work on file A, then it is perfectly fine for them to work. But if let's say developer one makes a change to the file A and submits it to the central server, then developer two has to do an extra step of merging his changes with the changes done by developer one and then pushing it to the central server. So yeah, you have to work out a system here. Yeah, and that is in all the version tools or systems, not specific to Git or SVN. Yeah. And then comes the various other technologies from the operations side which we loop into DevOps. So we have configuration management. That means we want to manage our infrastructure programmatically by writing small pieces of code so that development team can change those pieces of code and change the infrastructure configuration. So let's say if I want to update my system, let's say I have 10 systems for deployment, or 10 servers where the deployment happens, and I want to upgrade from Java 8 to Java 9, right? Instead of logging into each server, which needs admin permissions and specific skill sets for users to do it, a user can simply write a small or change a small configuration file, and that change is applied to all the servers. That is achieved by configuration management. Yeah, and there are various tools available for that. We have Puppet, we also have Chef, Ansible, SaltStack, and things like that, right? We can also package our applications for deployment using containers, right? Containers are nothing but small Linux processes which run in their own namespace, so they have their own security and isolation. And you can package your application along with all the dependencies. Like for example, if you have a web application and you want to bundle it up with your own version of Java and Tomcat, for example, and then deploy on, on a client side, then you can bundle everything together as a container and deploy it on the client side. Yeah. So again, containerization helps in making sure that your product is executed well everywhere despite the dependencies. And very important thing is monitoring. If you deploy your application, make sure that your application is running. Keep an eye on all the components of your application to understand if something is about to go bad, if your hard disk is going to be full for certain systems, if your databases are responding slow, or things like that. So keep an eye on all the components of your system. So that is achieved using monitoring, continuous monitoring. So you can use various tools like Nagios or Zabbix, or um, I think Splunk also works a little bit. So you can use any of these tools to achieve that. Yeah. So these are various technologies that are used in DevOps. And now I think you guys are fairly aware of what is DevOps and how it works. Naveen, you were right. So container means even Java and Tomcat along with your war will will get bundled together. So let me show you a small example on how we can achieve this. So I will just fire up a virtual machine on Google Cloud. Just give me half a minute, I guess. Maybe I'll start this one. So while we are waiting for the system to come up, please let me know if you have any other questions. Can I have the steps of for Jenkins installation and creating jobs in it? Jenkins installation should be easy. Jenkins.io is the place where everything about Jenkins is available. This is the homepage of Jenkins. Mhm. And you can, depending on your operating system, you can install Jenkins, right? If you want to install on Windows, Ubuntu, things like that, right? Jenkins has two releases, weekly and long-term support. So long-term support release is made every 3 weeks, every quarter, and it is kind of a stable release. Weekly release is made every week, and there are always new features developed in weekly release. So in production, always use LTS. Yeah. So for example, if you want to install on Ubuntu, you can click on that and follow the instructions here. So only two commands, one, okay, actually four commands, one and two, and these two commands. Yeah. So this is how you can install Jenkins. Pretty easy, pretty easy. So now my VM is up. I will connect to my VM. And quickly run a Docker Jenkins container so that I can demonstrate to you uh, how we can use Jenkins to at least achieve continuous integration. So while this is booting, just give me 1 second. I'll be quickly back. It looks like it is taking too much time. Let me retry connection. Okay, don't know why this is taking too much time. Question is, how can I download the presentation slides? I think Edureka will contact you. I'll give you a form. I was expecting a form to come from Edureka, but I have not received it. So I will let Edureka know, and they will contact you back with the class recordings and slides. Yeah. Okay. So we have one instance. I think there is something wrong with the instance too. So we have this instance. I will quickly become root. Okay. So I will quickly start my Jenkins using Docker. If you don't understand this, it is fine. Uh, we have not covered this at all, so it is okay if you don't find it, if you don't understand it. Yeah. So meanwhile, while my Jenkins is something is already using it. Okay, now it is fine. So meanwhile, to understand all these technologies or all the things that we have learned today. Yeah, there's an excellent course by Edureka called DevOps Certification, right, which covers uh, all your tools, right? That covers version control with Git, integration of Git, complete understanding of Jenkins, Maven, Selenium, Docker in detail, Puppet, Ansible, Kubernetes, Nagios, and a little bit introduction to cloud as well. So I suggest if you are trying to, or if you plan to enhance your skills on DevOps, then you should definitely take a look at this. Okay, take a look at this course. Let me know if you're interested. I can pass on the details to Edureka. So here is my Jenkins. Hopefully, yes, here is my Jenkins, and need to log in first time. Okay. So this is the initial setup of Jenkins. When you install Jenkins also, you will see all these pages. I don't know why these plugins are failing to install. Don't know. Looks like there is some version incompatibility. But it's okay if it doesn't install, it's fine. We can retry later. I will create my first user, which will become admin. Yep. And now I will go to the Jenkins homepage. So this is my Jenkins, right? I'm going to create a new job. I have a project on GitHub. Yeah, which is called this. So I will work with this project. So I'll create a freestyle project called uh, continuous integration. Yeah, I'll say okay. So I'm going to set up continuous integration on Jenkins, right? I'm doing it pretty quickly because, again, lack of time. So a lot of things you may not understand quickly, but I just want to demonstrate on how we can achieve this. So there is maybe some plugin dependencies which is causing these Jenkins to fail. And I think that is because of okay, maybe 2121. What Jenkins we have? Let's check our Jenkins version that is installed. Our Jenkins is 260.03. Okay, let's run with a new version of Jenkins. Says latest version is 260, right? But here we have 21762. That is a problem, right? That is the problem that we have. We do not have the latest Jenkins in our Jenkins. Let's see if we can have the latest Jenkins. Yeah, we can use 2187. So let's use latest Jenkins. Okay, some time lost, but it's okay. All right. So now it is going to install all the plugins. So there is one more question, I guess. Question from Raveen. We ran the command docker, meaning you have already installed Docker. So is it like this? After I install Docker, only then we need to install Jenkins. Somewhere to Docker, we need to mention Jenkins is present. Okay, so we are not. Docker is one of the way to run Jenkins. I am using that because it saves times. Saves time. It can be done pretty quickly. So that is why I'm using Docker. Otherwise, you can install natively, like with Windows and all that stuff, which I generally don't do for demos. Yeah. So And with Docker, you don't have to specify where Docker is installed. Docker will download its own Jenkins and run it for you. Question. Question from Anil. Hi Amit, I'm learning every day something new without background of IT and work in number of NGOs and enjoy all these learnings. Should I continue this? Definitely, yes. This is something which will definitely add value to your profiles. And at the age of 69, I really appreciate it. So please continue doing this. If you are able to cope up with the technologies, I will highly suggest to keep continue to do this. Yeah, and thank you for your persistence. So this is my Git repository where all my project is, right? So I'm going to work on this Git repository, and I'm going to execute Maven, and here I will say compile, yeah, and test and package and save. So I'm just going to do continuous integration, and I say build now. So what will happen is my code will taken, downloaded, and then what does it say? Maven, no such file. Okay. I need to do one more thing. Need to tell Jenkins where Maven is because it wants to use Maven, and I said already that Maven is not. I mean, Jenkins does not have any of its own intelligence, right? It has to do everything by using other tools. Yeah. So Maven, it did not know how to use Maven. This is a Maven-based project which I'm building. So it did not know how to use Maven. So now we are trying to achieve that again. Okay, maybe I should change the configuration. Use this Maven. So again, as I said, I'm doing things pretty fast. You may not be able to understand what I'm doing. A lot of questions you will have in your mind, which is perfectly fine. This session was just designed to make you understand, how you can think about DevOps and understand what DevOps is. Not getting into much detail, right? Getting into much detail is part of the complete DevOps course, which is around 36 hours. So yeah, it is humanly impossible to cover everything in 1 hour. Yeah, so I'm just trying my best to give you an initial idea on how DevOps works, how it looks like. So yeah, so now I have set up a CI. Yeah, and I can see that compilation is happening. It is downloading Maven and all dependencies of Maven to perform the compilation. Question coming in: red colors with a build failed. What are the other colors? Okay, there is blue color for Jenkins job here. So for example, red means build failed, blue means it is successful. There is also a plugin which you can use to change the color to green because green makes more sense. So blue or green makes build is successful. Yellow means that build is fine, but your test may be failing. Yeah. So yellow is like your compilation and all is okay, but some tests are failing. So now everything is successful. You can see my complete project has been built. Yeah. And come on. And I can see that if I go to my workspace, then my package is also created, addressbook.war. Now I can take this to the next step and maybe deploy it as well on a Tomcat container. Yeah. Question coming in: JUnit test, I understand. What is integration testing? Integration testing is testing your system along with other systems, right? For example, if you have a database, which is again a different component, so you should test that component as well for your complete system to work, right? Such kind of tests are called integration tests. So this was a pretty basic introduction to DevOps and introduction to various tools in DevOps, how you can work around with DevOps and all that. You can learn more by subscribing to the DevOps course by Edureka. And also today we saw a little bit of demo on how we can run CI using Jenkins. Again, could not explain many things in the demo, what I'm doing, why I'm doing certain tasks. So sorry about that, but we had a time limitation. And I hope to see you guys in the next webinars. We have a webinar planned for Jenkins. We have a webinar planned for, I think, let me check. We have a Jenkins webinar and we have Docker Swarm webinars coming up. Yeah. So yeah, maybe I'll see you there. Yeah. So thank you for joining today. Have a good day ahead. Enjoy the work, and I'll meet you next time. Thank you. Bye bye.